Now, this is the last one, and of course, it's the biggest one. But let's say you actually want to do some ranking. So you can do ranking. So again, I'm just generated a column like I did in the previous one, still calling it TSV search. I'm still concatenating the two, but I'm actually setting a weight now before them. So the only thing different about this compared to the previous slide was I'm setting the weight. I'm defining what I'm doing to the TS vector for the title. And I'm giving it a rank of setting the weight, I should say, to A. And then for the word being in the content, I'm giving it a value of B. So basically, I'm just ranking them to say prioritize data returned that appears in the title more than it's somewhere within the content. And still just concatenating it together, still adding the gen index. And then you can do queries like this, where, so I'm not just getting a count, but I'm actually getting the title, and I'm getting a float from 0 to 1, 1 being the highest rank. And I'm using a TS rank function. So this is a built-in Postgres function. I'm doing the rank against the TSV search that I built. That's the query I'm building, the to TS query. So essentially it's replicating what I'm doing in the where statement, but and then another value 0. Now I can't remember what that means, but anyway, but that's basically how you can do a rank that's going to show up on the screen when you do the search. And then you just need to order by that rank and descending, of course. So now your top ranked queries will appear first in search order. Now, ranking does take more resources. So, we've gone from 3 milliseconds to 36 milliseconds. So it's, starting to get slower. But I should add, this is actually pulling all the data. The previous execution wasn't pulling all the records. It was just doing a count. This has to do a lot more work to pull back to pull back that data to do the ranking and stuff like that.
So 36 milliseconds to search through a million-ish records with ranking between title and all the
entire
blog content
of the blog. Yeah.
With some random word.
Yeah.
Now, are we still whole word only at this point?
Yeah. Now you can do, yes, we're still doing whole word only, but you can use that colon asterisk to do a left anchored search through it.
Okay, so whole word or left anchored. Can I do I have the ability to do a find apple in the middle of this paragraph type thing?
Well, essentially, it takes that paragraph, breaks it by.
Sorry, not paragraph. Find apple in the middle of this word. It's not necessarily left anchored. Apple's probably not the best example, but that's the one we got. So let's say I had a compound word that, like, super applesauce. Could it find that?
I think you have to do an exact search or prefix search.
Okay.
Because, again, you think about how an index works. Then it'll do it, but it has to now resort to scanning the whole thing.
Right.
Because how would you find, because you think about it logically, if I'm going to a books index and I want to find all occurrences of apple, even if it's super applesauce, I have to know to go to super applesauce if I have the hopes of finding it, or I got to look through every single page.
Right. And, I can't think of a real good example where I would actually want to do that. I just like to think of ways to break things because chaos rules. So, it's just me.
Now, there's Now, this is again the full text search feature, and this handles a lot of use cases. There are instances where people want to do similarity searches or things like that. Now, I didn't cover that in this due to time constraints, and plus, we're doing pretty good on time
Yeah.
in terms of length. But there are there is a capability of doing trigram searches. So as opposed to breaking it up by word, you actually break it up into three characters, split everything into three characters. Even the white space is included within that characters.
Wow.
And that kind of helps you do more similarity searches, like give me things that are close to this. And with that type of searching, you conceivably would be able to find something similar to Apple within Super Applesauce.
Okay, so that's more of a fuzzy search type thing.
Yes. Yes.
But I have to imagine that index, like if I'm saving as I'm saving or updating records, that index is probably expensive.
Yes. Yeah. Yeah, that's, but when you're talking about a lot of data, then it does take a while to parse that stuff. But presumably if you're talking about like a blog post, you're not going to be doing that all that frequently,
Yeah.
doing the updates.
Right.
So, but yeah, like anything, an index is a burden on the, build and maintaining it side.
So it's all about the trade-offs. How much fuzziness do you want in your search versus how much time do you want in your index? How much weight do you want? At some point you'll rob Peter to pay Paul somewhere.
Yeah. But anyway, so this is kind of an introduction to how to use primarily full text search to speed up your queries. If you keep doing like and I like, and they start becoming dogs,
Here you go.
these are two options: either the text pattern ops for doing a left anchored search on with a B tree index, or using full text search. If you like this clip and want to watch another one, you can click right here, or if you want to watch the full video, you can click here.